Hello, space explorers, and welcome back to our channel. When you picture a planet with rings, Saturn almost certainly comes to mind, with its magnificent, icy, and incredibly bright system. But did you know that Saturn isn't the only gas giant in our solar system with a set of rings? Jupiter, the king of planets, also has a ring system, but it is so faint and ethereal that it went completely undiscovered until humanity sent its first robotic explorers to the outer solar system. Today, we're diving into one of the most intriguing celestial mysteries. Why are Jupiter's rings so incredibly faint? Let's unravel the story of these ghost-like structures. The discovery of Jupiter's rings was almost an accident. When the Voyager 1 spacecraft flew past Jupiter in 1979, scientists took a long exposure image, not really expecting to find anything. They were looking for small, undiscovered moons. To their astonishment, a faint, thin line appeared, encircling the giant planet. It was a ring, but one unlike any we'd seen before. It was dark, dusty, and almost invisible. This discovery was later confirmed and studied in greater detail by the Galileo orbiter, the Hubble Space Telescope, and most recently, the Juno mission. So, what makes these rings so different from Saturn's glorious halo? The answer lies in their composition. While Saturn's rings are made primarily of bright, reflective water ice, ranging in size from tiny specks to chunks as large as a house, Jupiter's rings are fundamentally different. They are composed almost entirely of micron-sized dust particles, about the same size as the particles in cigarette smoke. These tiny specks of rock and dust are incredibly dark and don't reflect much sunlight, which is the primary reason they are so difficult to see from Earth. If Saturn's rings are a brilliant disco ball, Jupiter's are like a faint wisp of smoke. This raises an even deeper question. Where did this dust come from, and why is the ring system so narrow and tenuous? Unlike Saturn's massive and ancient rings, Jupiter's system is believed to be young and dynamic. The leading theory is that the rings are not a permanent feature but are instead constantly being replenished. The source of this fresh material: Jupiter's innermost moons. Jupiter has 4 small moons orbiting within its main ring system: Mytis, Adrastea, Amalthea, and Thebe. These moons are relatively small and have weak gravity. The space around Jupiter is like a cosmic shooting gallery, filled with micrometeorites, tiny, high-velocity particles of rock and ice zipping through the solar system. When these micrometeorites slam into the surfaces of these inner moons, they kick up clouds of dust. The impacts are energetic enough to eject this dust into orbit around Jupiter. Think of it like hitting a dusty rug. Each impact sends a puff of material into space. Because the moons are already orbiting Jupiter, the ejected dust naturally falls into a similar orbit, forming a ring. This process is known as impact ejecta. The gravity of the parent moons helps to shape and confine this dust, but the particles don't stay in the ring forever. Various forces are working to remove them. One of the biggest challenges for dust particles in Jupiter's rings is the planet's powerful magnetic field. Jupiter has the strongest magnetosphere of any planet in our solar system, and as it spins rapidly, this magnetic field drags charged particles along with it. The tiny dust grains in the rings can pick up an electric charge from the surrounding plasma. Once charged, they begin to interact with the magnetic field, which can pull them out of their stable orbit and cause them to spiral down into Jupiter's atmosphere. Another force at play is something called Poynting-Robertson drag. Sunlight, even as far out as Jupiter, carries momentum. When photons from the sun hit these tiny dust particles, they exert a minuscule but constant pressure. Over thousands of years, this gentle push is enough to cause the dust particles to lose orbital energy and spiral inward towards the planet. It's a slow but relentless process that effectively cleans the ring system over time. So, Jupiter's rings exist in a delicate and fascinating balance. They are constantly losing material to Jupiter's atmosphere due to magnetic forces and solar radiation drag, while simultaneously being replenished by fresh dust kicked up from its inner moons by micrometeorite impacts. This continuous cycle of creation and destruction explains why the rings are so faint and dusty. They simply don't have the time to accumulate into a massive, icy system like Saturn's. The material is always on the move, a transient feature of this giant world. Let's break down the structure of these rings, because it's not just one single band. Jupiter's ring system is actually composed of three main parts. The innermost and thickest part is called the halo ring. It's a donut-shaped cloud of dust that extends from about 92,000 kilometers from Jupiter's center out to about 122,500 kilometers. This halo is puffed up because the dust particles are being pushed around by Jupiter's powerful magnetic field, giving it a fuzzy three-dimensional shape. Next is the main ring, which is the brightest and narrowest part of the system. This is where the moons Adrastea and Metis orbit, acting as the primary sources for the dust that makes up this ring. The main ring is only about 6,500 kilometers wide, and it's much flatter than the halo. Its sharp boundaries suggest that the gravity of these two small moons plays a crucial role in shepherding the dust particles and keeping them confined. Finally, extending far beyond the main ring are the two gossamer rings. They are named for their extremely faint, almost transparent appearance. These are incredibly wide and tenuous sheets of dust. The inner gossamer ring is sourced from the moon Amalthea, and the outer one is sourced from the moon Thebae. Each gossamer ring extends from the orbit of its parent moon inwards. When you look at images, you can see how the dust forms a faint trail leading away from each moon. A beautiful illustration of this replenishment process in action. The study of Jupiter's rings has completely changed our understanding of how ring systems can form and evolve. It shows us that they aren't all grand, permanent structures like Saturn's. They can be dynamic, temporary, and intimately linked to the moons that orbit within them. This dusty ring model has since been applied to the other gas giants, Uranus and Neptune, which also have dark, narrow rings likely formed by similar processes of moon impacts. So, while they may not be as spectacular as Saturn's, Jupiter's faint, dusty rings tell an incredible story of constant change, cosmic collisions, and the subtle interplay of forces that shape our solar system. They are a testament to the fact that even the most empty-looking parts of space are filled with hidden wonders, waiting to be discovered. The next time you see a picture of Jupiter, take a moment to imagine that faint, ghostly halo encircling the giant, a beautiful and dynamic system powered by the dust of its tiny moons. What an incredible cosmic dance of creation and destruction. It really makes you wonder what other hidden structures are out there in our solar system and beyond. What are your thoughts on Jupiter's ghost rings? Let me know in the comments below. If you enjoyed this deep dive into one of the solar system's best-kept secrets, please give this video a thumbs up and consider subscribing to our channel for more journeys into the cosmos. Thanks for watching, and as always, keep looking up.